Hello everybody, my name is Juan Sebastian Carvajal. I am a civil engineering master student at the University of Maine under the guidance of Dr. Aaron Gallant, Dr. Aaron Brasha from the University of Rhode Island, and Dr. Keith Berubi from the Department of Mechanical Engineering Technology at the University of Maine. My research project is about lateral and torsional resistance of helical piles using a novel color vane. So a helical pile is a deep foundation element designed to support axial loads. However, due to its limitation to support lateral and torsional resistance, it cannot be used to support structures like traffic signs or signal poles. So to overcome this limitation, a collar vane was attached near the head of the helical pile to increase the torsional and lateral passive resistance. So this figure 1, shows the installation sequence of the collar vane into the helical pile. The first step is to install the helical pile into the ground by means of a grout and a torque motor. The second step is to install the vane. The vane is added into the shaft element and is bolt. The two sections are bolt together. Then the installation resumes and the collar vane is just being the helical pile is rotating, but the collar vane is static. It's just being pulled into the ground, and finally the collar vane is connected structurally by bolts to the helical pile. So the experimental program, the helical pile was installed and tested in a medium stiff clay in Centralia, Missouri. We perform a cone penetration test, a standard penetration test with disturbed samples recovering for index parameters, as well as the field shear vane test. A quick load procedure was used to complete the testing program in a timely manner. The helical pile was instrumented with 8 strain gauge locations along the shaft to measure bending strain. And to perform the torsion test, we use a 3-meter long loading arm that it was relatively stiff, and it was connected at each end by a separate load cell and cylinder, so we can apply a pore torsion load. So the results are, in the case of the lateral test, the red line is the base case, that is the helical pile without the collar vane. The helical pile is only 3.5-inch diameter, so it's a slender element. So this is part of the issue where helical piles don't provide enough lateral resistance. And so when we include the vane, it adds some resistance as the size increases. In this case, the collar vane 36-24, 36 is the diameter in inches and 24 the height, also in inches. The figure 3b shows the normalized force, so it's the lateral resistance that is 10, 15, 20 times as much as lateral as without collar vane. So for the bigger vane, the 36 by 36, it needs more or less like 20 times to displace the pile 10 millimeters as without collar vane. So here in this figure, I'm showing another big factor about the collar vane, that is the amount of resistance in the shaft compared with what would be if there was no collar vane. So for the case of the bigger vane, I am almost reducing same times, 100 times the amount of bending moment in the in the shaft. So this is a big contribution, because if we reduce the bending moment by just putting the collar vane, we can this eliminates the need of a big diameter shaft, so making the pile more optimized and reduces the cost of installation, and installation is gonna be easier. So, and finally here I'm showing the torsional results. So this is the torque versus the angle of twist. I am also showing the base case, that is we applying torsion to just the helical pile, and the ultimate torsional capacity was close to 7 kilonewton meter. And when we put the vane, we can increase these values, this torsional capacity, and we reach, using the biggest vane, we can increase this capacity up to a factor of 10 times. So yeah, this works. So the conclusions are like the usage of helical piles provides constructions and design advantage. So helical piles are relatively inexpensive compared to drill shafts, and is easy to install. There is no a lot of soil disturbance. So also the resistance is transferred through the flange, so reducing the shaft movements and giving more efficient pile properties. And another conclusion is the vane is located at shallow depths, so where the pile mobilizes most lateral resistance, and it makes a more efficient pile design. Thank you.